And you see the countdown?
Yeah.
All right, welcome to the next session. I'm here with Emily Mellish from Multitudes. Emily we've been talking backstage, very dynamic person. Interests include blowing up circuits, riding horses, and rockets. And some of that is work and some of that is play. It's 6 a.m., her time zone. She's here at great personal sacrifice, um, turning down social invites. She's here on the tail end of data invites and is hanging out with some great people. So, Emily, thank you for being here, and I will turn the time over to you.
Awesome. Thank you so much. All right, let me just share my screen for y'all. Cool. All right.
It looks good.
Yes.
All right, take it
Awesome.
away.
Great to hear. Thank you. Hope we didn't get any of that awkward mirroring effect going on. Cool. So yes, hello. My name is Emily, and it's a really awesome pleasure to be here speaking. I guess it is virtual, but this is my first US conference I'm speaking at. I am from New Zealand, which means yes, it is 6 a.m. in my time, but that's okay. I'm really happy to be here. And in case you can't tell from the title of my talk, I've had a rather interesting journey into data engineering. So today I want to share with you some of the lessons I learned from building pipelines at 3 very different companies, but the problems were all very similar. But before we get started, couple of disclaimers. One, opinions are entirely my own. New Zealand is far away from the rest of the world, so we kind of just have to build stuff and do stuff without really knowing what else is going on. So I really just kind of forged my own path into data engineering. I didn't know I was a data engineer until about 4 years ago, despite working in data engineering for like 7 years. So that, and then 2, hopefully for obvious reasons, I can't go too much into the rocket part, but I will try my best to share some photos and talk about the cool stuff. But first, a little bit about me. So I am a cyclist, a horse rider, and according to a very expensive piece of paper, which I am still paying off, I am actually an electrical engineer. So during university, I interned at 2 companies in New Zealand. Number one was Trade Me, which is kind of like New Zealand's Amazon, but I worked at the car selling part of that. So I worked with a lot of car dealer data. So I worked as a developer, but in working there, I learned a little bit about sort of data processing and all the information and insights they were giving to car dealers, and was like, oh, this data thing's pretty cool. Then I went and actually worked as an electrical engineer rather than a software engineer. So I worked at a company called Flexware. They were an engineering consultancy, and I actually was wiring up tree harvesters, so the big things that pick up logs. I was doing a bunch of that, which was very cool and nice to get that experience. But then, of course, I went to Rocket Lab. So Rocket Lab is New Zealand's SpaceX. So we do launch rockets in New Zealand. It's pretty cool, especially as a New Zealander. Obviously, to work at something like SpaceX or NASA, you have to be a US citizen. I was a huge space nerd, so being able to work with rockets in New Zealand was awesome. So this is obviously the rockets part of my story. So at university, I specialized in power electronics and machine learning. So machine learning was the cool kid on the block at the time, before it became AI and Gen AI and all that. And so I really wanted to get into data science. So at Rocket Lab, I really wanted to do some data stuff, and I'll go into that in a little bit. But yeah, sort of studied that realm of field to go into data science specifically. And then after Rocket Lab, I was at Halter. So Halter is an ag tech company, and they do collars for cows. It's kind of like FitBit for cows. So they log a bunch of data about the cows, as well as geofence them, get them ready for milking, get them ready for breeding, etc. Very interesting New Zealand startup who have actually just broken into the US at a ranch in Wyoming, which is pretty cool. And lastly, where I am now, which is Multitudes, who empower engineering teams to deliver code faster without burning people out. So we do a lot of analytics around developers. So that's the developers part of my story. But first, rockets. So straight out of uni, I joined the propulsion team at Rocket Lab as a propulsion software engineer, kind of in the hopes of doing some data science. And the following problem was posed to me. We want to predict engine issues before they become a problem. So at Rocket Lab, they have engines on the rockets. So the Electron rocket, which we launch, has 11 engines on it. And there is a whole team to test these engines, something to test them, that they work before flight, and then make sure that the engine's all good to put on the rocket, and also compute some parameters. So there is a team of people. They all work in like a container or a bunker to test these engines. There's a lot of people and a lot of rockets to test. So obviously it's quite hard to like look through all of that data and know if the rocket is actually good for flight. Therefore, it would make sense to, okay, we need to use some sort of data science, machine learning, anomaly detection to detect if there are issues. So me being, a fresh little grad and having done machine learning at uni and also done some courses online, I was like, awesome, yeah, we can definitely like do some anomaly detection. We can do some models, like let's go. And then I was like, okay, where's the data sets? And they're like, oh, no, we don't really have any data sets. Like we have an Excel spreadsheet and we run some like tests and like the data goes somewhere, but we don't really know. And I was like, oh, okay. I guess I just have to like build the data set then. So Q having to build the data set. So when the rocket goes on the test stand, there's a lot of sensors that send data back, like pressure sensors, mass flow rates, etc., even things like vibrations. So there's data anywhere from the hundreds to thousands of kilohertz, as well as some ground station software, which has like the most hideous data formats you've ever seen. Like if you thought JSON was bad, TDMS is the worst. So I had to process these really terrible files, massive amounts of data, and they had to be processed after every test. So it had to be very, very fast, because obviously engineers have done the test. They want to see that the rocket's all good for flight so they can take it off the stand, put on the next one. So yeah, it had to be very fast and process like a lot of data. But the one thing about Rocket Lab was that we weren't allowed to, because the inherent nature of space tech, nothing could be on the cloud. So everything had to be on-prem, self-managed. So I had to run my own databases, my own servers. I had to use very vanilla Python for the processing. Like I wasn't able to use like open source libraries or anything. So that was a really good learning experience, because you just had to know everything about what you were doing. You couldn't just offload it to some external system. And then, yeah, in terms of the data, we had it in Postgres, timescale DB, and then Python for all of the processing. And then we had C#.NET applications for the engineers to go and look at the data, which was really, really cool. So yeah, it was a really, really fun experience. I built up sort of all of the data sets. I actually had a database named after me when I left the company. But one of the most memorable things from my time there was I was actually there for the first successful launch of our Electron rocket. Knowing that I had verified these engines for flight, my code had sort of done that, and then also my data pipelines had set some parameters for flight, but also knowing that my code and data had set some parameters and verified these engines for flight, and being like, is it fine? Because being every day at the test stand and seeing what could go wrong with testing these engines, and like how finicky things were and how hard rocket engineering is, it was very scary watching this, and hoping that it was going to work, knowing all the things that could go wrong. But thankfully it did, and it was just a really, really cool moment in my career to see that, watch it with my team and mission control. Yeah, very cool. So at Rocket Lab, built up the data sets, which was great. But unfortunately, I actually left before I got to the data science. So I, after Rocket Lab, moved to Halter, which is the cows part of my story. So Rocket Lab was great. I really enjoyed my time there, but there was a really cool new startup coming in New Zealand with dairy cows. Obviously, as a horse girl at heart, I was like, oh, like it'd be really cool to work on a dairy farm. Like, always been interested in that. And so Halter, as I mentioned, they process a whole bunch of data off cow collars. And so when I first joined, the following was posed to me. We want to predict cow behavior and pick up on issues before it becomes a problem. So can we detect that a cow is lame or sick before the farmer knows? And can we make sure we can separate the cow out and before the cow has to get a vet out or something like that. And so when I joined Halter, I was like, awesome, yeah, we can definitely do that. Where is my nicely curated data set of cow behavior? How can I do that? And of course they were like, oh, no, we don't have one. Like, I just thought you could, AI, black box, all good. Like, you don't need data. I was like, oh, no, I kind of need data. So QME again being like, okay, I guess I'm just gonna have to build the data to be able to actually do data science. So QME building the data again. So what Halter is, we want to predict cow behavior. So we want to do look at how often a cow is grazing, if they're walking a little bit funny, and we want to be able to detect if they're ready for breeding and therefore improve cow well-being. So you can see in the photo, in the top left is the van that we would drive out into the paddock. It had a generator attached to it at the top there. It had some security cameras and networking. And then inside the van was an NVR, which is like a video recorder. So we would drive this into the paddock and just sit it there for however long the cows were in the paddock for and video them at every single angle. And then you can see in the right, we have cows in like coats with big numbers. So that is so our cow behavioralists, so people who would sit and watch cow videos all day, they could know that, okay, OA, she is grazing now, and then which collar is OA wearing? Okay, OA is wearing this collar number 2, link up the data, and then be able to know, okay, label that data as cow grazing. Because there was no data set for this in the world. So we had to build it, which was an interesting time. So in terms of the data, we had about only 10 hertz of data from the cows. And this was anything from GPS, accelerometer data, gyroscope, etc., just looking at cow movements. And then, yes, the videos were labeled by what we call our cow behavioralists or analysts. So yeah, there was literally like a team of 4 people labeling videos all day so that we could build our data set of what a cow grazing looks like. In terms of the tech, so thankfully I was ingrained into the wonderful world of serverless and cloud, because at Rocket Lab didn't have any of that. So at Halter there was an amazing DevOps guy that I learned a lot off, and so I was able to do learn all of the sort of more new age data processing stuff. So all of the data off the collar was streamed via Kinesis data hose to data analytics and then chucked into S3, then spinning up Glue to then process it into Athena, spin up our Spark cluster, run some PySpark, and then be able to view the data in Tableau. Then after that, looking into like SageMaker and things like that for our machine learning models. But again, unfortunately, I was there for 2 years building up this massive data set. I actually became a dairy farmer at one point. I was fixing the generator on the van. I became a security camera expert to do all of this. So very varied job because we just had to get the data. But again, kind of didn't get to the data science part. So they are doing all sorts now. So they now can predict grazing, heat, etc., which is pretty cool from the data sets that I created. But basically a new opportunity came up before I got the chance to be a data scientist. And kind of by this point, I was like, I'm an engineer. Like I really do enjoy building stuff. and I realized that like, oh, like data engineering is actually a thing. And so I was like, I actually don't think I want to be a data scientist anymore. And I think that's quite a common like pathway that people end up in data engineering. We're kind of like failed data scientists because companies just hire you as the first data scientist, and then you're like, oh, there's no data. I have to just make it. So yeah, I was basically like, okay, I'm a data engineer. That is my job now. So Q, the developers part of my story. So basically Multitudes started, and I had the opportunity to be basically the first technical hire, which is a really cool opportunity to go from sort of startup to startup to startup and go like smaller and smaller. So I was basically asked to be, the technical hire, which meant I had to build everything. So not just data, also APIs, etc. But the following problem was posed to me. We want to predict team behavior and performance before it becomes a problem. So, especially in big teams, managers have certain blind spots around like who maybe is struggling a bit more, why is work getting blocked, how long are pull requests taking to get reviewed, etc. But by this point, I was under no illusion that there was a magical data set waiting around for me, although there is actually reasonable data sets on the internet for things like this, like Google's Dora research in space, etc. But I did know that I had to build the data. So in terms of our use case, we want to provide team well-being and performance metrics to help software development teams improve. So that is like maybe you're doing a lot of out of hours commits. Maybe someone in your team was paged at like 3 a.m. last night, and we can look at all of that data and be like, hey, you should maybe check in on this person. Also, maybe your code delivery is really fast, like you're getting lots of pull requests onto production, lots of features out into production, but that's at the expense of team collaboration. Maybe like no one's giving code reviews and code's just going out like really, really fast, which is not really what you want either. So we kind of put all the metrics together to figure out, in what areas can you improve, not just looking at one metric, but across all of the metrics, across all of the tools that you would use. So we plug into GitHub, Jira, Linear, PagerDuty, Google Calendar, etc., to look across your whole team, what's going on. So the data, relatively real time from GitHub, Jira, Linear, PagerDuty, on various events. So things like pull requests when it's opened, closed, merged, reviewed, etc. Issues when they're moved into the cycle, how long they take, the different types of issues that you're working on, and then PagerDuty incidents. How long are you taking to resolve an incident, and how often is your team getting paged for incidents? So because we're kind of working in like a dashboard thing, we don't really need the events to be super fast. We don't need the data to be super fresh. So even though we ingest the data in real time from like a webhook, we only process it every 6 hours, just because real time is scary and expensive. So I was like, oh, we just need to process it every 6 hours. You don't need data faster than that. So in terms of the tech, I have come a long way. This is our sort of first infrastructure pass, but nowadays it's a little bit more involved. So a lot of Lambdas and AWS step functions, which is really cool. So then ECS for data wrangling, we run like a Python task on ECS, so we're a lot more serverless. And then of course DBT, Snowflake, Python, could finally use pandas, unlike at Rocket Lab. And then we just have a nice Postgres table for the data at rest. So once, onto the API sit on top of that. So that's just like really nice, love Postgres. So yeah, it was really, really cool to build this data pipeline like completely from scratch. And then basically be able to keep maintaining that, be a data engineer. I no longer have to do the data science. Thankfully, we have lovely data scientists to do that for us. So yeah, basically 3 very different companies, 3 very different types of data. But despite that, the lessons that I have learned from working at these 3 companies are all very similar. So I want to share with you some of those lessons. Just build it. You don't need fancy tech. You don't need the latest data engineering tool to start. Yes, you know you may get there eventually, but sometimes you just need to start building stuff. And so how can we build stuff fast? I've worked at startups. It's all about just building as fast as possible. Obviously still thinking about security and making sure your product isn't terrible, but you want to be able to build quickly so you can iterate quickly. So number one is Lambdas. I love Lambdas. So in AWS, just a bit of code that spins up when you ask. Actually, our very first data pipeline at Multitudes literally just was a single Python Lambda. Obviously, that eventually stopped working due to like memory and timeout issues. So we had to move to ECS, but it's a really good way to get started. And then you can use things like step functions and things to orchestrate your Lambdas. So you can have like a few kind of Lambdas going off. So you don't need like a fancy DAG tool. You can just have some little Lambdas that are doing stuff, and it's perfectly fine at the beginning. And number two, use the languages you know. Like if you don't know Rust and you want to use Rust because it's the cool kid on the block, that's great, but you're probably going to slow yourself down a lot. We actually at the time were looking, when I started Multitudes, we looked at Go because that was the kind of, the cool language on the block. And I tried to use Go and I was like, I have no idea what I'm doing. I'm just going to go back to like JavaScript and Python. And then same at Rocket Lab. They were like, you just need to build this data thing. I was like, okay, I know Python, so I'll just use Python. You don't have to unnecessarily slow yourself down to use the latest and greatest languages out there. And especially with things like serverless nowadays, everything's becomes very distributed. You can always, you can spin up a Rust Lambda in a year's time and have a play with it. Like at Multitudes, we're now investigating like polars and Rust for our data processing. So, it does come in eventually, but at the beginning, you just want to be as fast as possible. And number three, get to know your customers. So at Rocket Lab, I was a propulsion team member. So I would sit and test the rockets with them. I would see them use my software, use the data, and sort of see what worked, what didn't, what did they need to know, and what was kind of, secondary, what could be in the report. And that was just really helpful because I was just literally like in the test container, like writing the pipelines next to them as they were testing the rockets. So that was really fun experience, and I was able to sort of build something that really, really worked for them. Same at Halter, I became a dairy farmer. I was bringing the cows in for milking at 5 a.m. So, an hour earlier than now. I was fixing generators. I was a diesel mechanic, security camera expert, as I mentioned. So I really got to know the farmers and what they wanted from this data. And then at Multitudes as well, I kind of cheated a little bit because I am a developer. So I kind of technically was a customer, but I still try and sit on UX calls all the time. So, we'll have calls with customers, talking to them about how they use the product. And I think that's just super useful. I know it's like maybe as data people, we don't think we need to do that, but it's super useful, especially because your customer may actually just be internal. Like maybe your customer is just your data analysts in your company, or your marketing team, or your sales team. Sitting down with them and learning like what they need to know from this data, how they use it, is super helpful, because you may be maintaining this table over here that no one uses, but then there's this other table that you haven't really fully maintained, and it's like super critical for the BA team or something. So yeah, really work with your customers. Number two, automate and codify it. No one wants to be like manually in the AWS console, like setting up pipelines and databases and Lambdas. I really love just being able to automate everything, go through CI/CD, and not have to stress about like if I set something up in production versus dev, the same. So in terms of tips for automating, Terraform all the things. I love Terraform. As a data engineer, it is like one of the most useful tools. Thankfully, I learned this at Halter. They just had like this DevOps guy who was a Terraform machine. So I learned everything I could from him. And it's just super useful. We have like a dev staging in a production environment. It's all Terraformed across Snowflake and AWS. So we know that when we go to production, the pipelines are going to be the same. Which is just very, very handy. And then we have completely segregated like data pipelines and everything. So all the data's yeah, coming through all the same systems. If something goes wrong in dev, we know we can fix it and before it goes to production. So yeah, love Terraform. And then part of that as well, multiple separate environments, like ideally don't just test in production. No one wants to do that. Having them completely segregated. So yeah, in AWS and Snowflake, we have completely separate accounts. So like there's no possibility for overflow. And it's just really helpful for keeping our production data safe, but at the same time being able to do all the tests and things we need to do without worrying about mucking up a production data pipeline. And then, of course, I'm sure we all know that we should just, do unit tests and end-to-end tests where possible. At Rocket Lab, it was very scary because you were computing parameters for the engine. And there were times when there was just a slight, off by a factor of 10 error, and it was a very scary day. So yeah, definitely like test your outputs. Are they what you expect? Are they in the expected range? And then unit test that as well, so that if you change something in your data pipeline, you break something, before you have the chance to, unfortunately, cause some terrible accident. So yeah, very important. Number 3. I know everyone loves talking about schemaless, but I honestly think there's no such thing as schemaless. Maybe at the beginning, but like everything needs a schema eventually. Like your data has to be useful to someone. It can't just sit in this like massive data lake forever and not do anything unless you decide to like go and parse all of that JSON. So yeah, everything needs to have a schema. What is it? How often does it come in? What units is it in? Etc. So tips for managing your schema. You can't mess up the schema if there is no schema. But yeah, really document your data at each stage. So I got really good at sort of literally just a wiki page of like, okay, here's what the data looks at the raw form, here's what it looks in the transformed form, and here's what it looks like when it's enriched with all of the metrics or whatever. And that at Halter became like the golden page where people could go and see like, okay, what is this data? Where is it coming from? How often? What units? Because you don't know who's necessarily needing access to this data. And therefore it's really useful to have like the wholly information of what it is. Also, attempt to version control your schema. That's why DBT is really good, because you can have it all in a GitHub repo, make any changes that you need to make, and then have that all set. And then as well with like Glue catalog now and stuff, you can actually just version your schema completely, which is really nice. If there's changes, it doesn't mess up with previous things. And then also, just split the data based on event type and source. At Multitudes, we have a lot of data from a lot of different sources, a lot of different event types, and it's just much easier to like split it up into, this is a pull request table, this is a commits table, this is a comments table, rather than having it all in one and then trying to like build SQL on top of that to parse that out. And it just makes everything, your schemas and everything much cleaner. So lesson number 4, secure it. So I'm a big listener to hacker podcasts. Darknet Diaries is one of my favorites. And so from that, I learned that nothing is safe on the internet, and you're never too small for hackers. Like, despite the fact we're a little New Zealand startup, I still am really like focused on security. Like, I'm not just like, oh, we're so small, no one's going to care. I am really concerned about security, and you should think about that from the very beginning. So some things to think about. Who has access to this data? I know it's really easy as data engineers to just be like, everyone gets access, it's much easier, it's fine. But, does the sales team really need access to all of the log data from the Halter collar, say, and then, does the engineering team need access to very specific data team data? Like, maybe not. So sort of like restricting access to things really helps, because if something, if a computer were to get breached, at least like they don't have access to everything. And that seems to be a very common case at the moment. Like the Snowflake breach was someone's computer having access to a lot of data. So it's like, the way they're going to get in is probably through someone's machine. And so can you restrict what access they have, so it's not going to be like a massive security breach? And number 2, do you need to store PII? So like personal information. Thankfully, at rockets and cows, there wasn't really a PII like in this. Like, I guess a cow has an ear tag, but we didn't really have to worry about that so much. But at multitudes, we do store potentially sensitive data, so we be very careful about how we link up who is who. And we basically use like kind of hashed IDs throughout our whole system until the very end point where we link up, okay, this person is this person in GitHub. Because we want to be very careful about storing that information, and like we don't store anything we don't actually need. So, we don't store gender of people, we don't store ages, we don't need that. So, if you do have to store people data, just think about, do you actually need to store these things? Because it's much easier, even for compliance and stuff, to not have to store that kind of data. Lastly, as well, great to have encryption, all of that, but make sure you do rotate your keys. You don't just like leave the same keys on forever. It is a little bit annoying to have to like rotate them all the time, but it's much better security, especially if some old developer's machine gets compromised. Hopefully none of the keys on there will actually be able to do anything. So Terraform really helps with this, and it's just a really good thing and really good practice to get into. Number 5, make it ethical. So it's also an easy thing to say that we're small, we don't have time for data ethics and to think about that. But I do think data ethics also starts at the beginning. Again, rockets and cows, we didn't really have to think too much about ethics other than, some animal ethics. But at multitudes, we are processing people data and potentially sensitive people data, what you're writing in a JIRA ticket, how you're writing code, etc. So from day 0, we were like, okay, we need to like think of some core principles and make sure we stick to them in terms of our data. So our sort of 5 key data principles that we live by are autonomy. So we give people control over how their data is used. You have a say, and then as well, if you were to leave multitudes or you were an individual who didn't want to be on multitudes, we can completely erase your data. As I'm sure you know, that can be hard to do when you have like data lakes and warehouses and all these things. But from the beginning, we made sure everything was like partitioned or like keyed on the organization or the team member IDs, so that we could just very easily remove that data should we need to. Reciprocity, just the classic Jurassic Park theme, like just because you can do something doesn't mean you should do something. So we're all about like, we're only going to collect your data if we can actually get value from it. Like, we're not going to just collect all of this data on you for our own benefit. We really want to make sure you get something from it as well. And then we want to create a positive impact for people. We don't want to be using data in a way that is harmful. We want to make teams better. We don't want to have someone looking at how many lines of code did you write and who wrote the least lines of code. We really don't want that. We want to create a positive, like healthier team environment. And then context, as everything, and data is just a number. It's a very helpful discussion starter, but we need to be able to put that into context of the humans around us. So maybe this data is looking like this, but what discussions can we have as a team, and like what else around us leads to that? And then accountability, we sort of have these principles, but we want to make sure that our customers know they can hold us accountable. Tell us when we make mistakes, when we get stuff wrong. Because we just want to build like a more transparent data company. Cool. So in summary, our learnings are just build it, just get started, whatever tech just go. Automate and codify it, Terraform all of the things. Make sure you have nice code repositories, ideally not on your local machine. There's no such thing as schemaless. Everything needs a schema eventually. Secure it. You're never too small for hackers. Make sure you secure your things, and make it ethical. So really think about data ethics from the beginning. It makes it much easier when if you do get bigger and you do suddenly need to think about that. So what do cows, rockets, and developers all have in common? Well, they all create data, and that data can be made useful to improve their daily lives. I feel like inherently that's often what we do as like data scientists, data engineers, is we're using data to hopefully make things better. And despite the fact that these were, three very different data sets and companies, the end goal was the same. And also the problems were the same. I think that's the really, really cool thing about data engineering is you could go into any company. Your skills are still valid. You might have to learn a little bit about the domain. What does cow data look like? But you can use your skills to build data pipelines, work with really cool people. And yeah, it's just a really, really cool field to be in. I'm so glad that I have found my way here. So yes, I am Emily Mellish, and thank you very much. Happy to take any questions anyone has.
Hey, so got a couple of questions in the chat. First one's mine because I need to clarify this. As a
Yeah,
data engineer, you milked cows?
I did. Yes.
And was that, I get the sense that you brought, it wasn't a job requirement. You're like, no, if I'm going to do my job right, I need to milk cows.
Yeah, correct. Yeah, I wanted to learn a bit more, and because of so we had to kind of split up the herd to do the videoing because we wanted like, I don't know, 50 cows, and there was a herd of 300 cows, say, and much bigger paddocks, harder to video. So we had to split the herds, which meant the farmer was like, you can do that, but you need to bring that herd into the shed for milking. And so that's why, like, yeah, to get this data, we had to like herd our own cows, build our own fences, bring the cows in for milking at 5 a.m. for the farmer, like keep them separate, and then like take them back into the paddock afterwards. And then yeah, I was like, I kind of want to milk a cow. It is hard, like it is. They do it so fast. But yeah, it was a fun time. Really cool to just like learn all about that whole industry.
I physically sat with the accounting team, and that was a cool story up until right now. Like
Oh,
I love that. I there were so many parts of your talk where I was like, me too. Yeah, I also was part of a team that picked up Go because someone thought it was cool, and I was like, that's what you didn't share was that's actually a very painful thing to do. I love Go, but it's not
yeah,
Python. It's
it's
not.
not Python.
There's no import pandas the way
No,
there is.
no,
And that's a
no.
plus and a minus. It's a plus
Yeah,
and a minus. I actually do like Go a lot, but I also like to import libraries and have
yeah. I would one day I'll learn it.
one day. Uh, so one of the questions. Uh, so I've heard of Terraform. I'm superimposing. I've heard of Terraform. I've read it in job descriptions and then said, well, I guess that's not for me, and moved on. So from that perspective, this question, I think they're actually implementing Terraform. It
Mm,
says, hold on, I lost it. How is your process of going from the
yes.
traditional UI to Terraform? We have an ongoing cloud infrastructure and find it challenging to migrate to Terraform. So
Yeah.
from a perspective of someone who might not be that familiar with Terraform, could you talk about that type of a project in your experience?
Yeah, for sure. I guess I was a little bit lucky because most of, Halter had a very established Terraform. And so I sort of learnt, some good Terraform principles from Halter. So they would have like, they were microservices, right? So they would have a repo, and then inside that repo would be like the code and then the infrastructure for that code. So, maybe it's like an ECS server, a Lambda, some Lambdas, and a couple other things. So I think that was a really helpful thing to like segment your Terraform. So, this is this very specific server, this is this API, this is that API, which is very helpful. And then from there, like we will literally just have like, lambda.tf, ecs.tf, s3.tf, like just segment things then into the like AWS kind of types. Don't
Mm-hmm.
have a giant Terraform file. In terms of going from the UI to Terraform, I know there is something that you can like read in your Terraform state from AWS or cloud, Google Cloud, whatever it is, and then like get the Terraform for that. It's not the greatest from memory, but I guess my advice would just be, just start slow. Just pick like one service. Look in the UI. Like I still to this day, like if I have to build a new service, I will still look in the UI and be like, okay, what are the parameters in the UI that I need to set? Like in my dev environment, I'll like, spin up this new service. Like what did I have to do recently? I had to put like a Lambda inside of VPC. So like a like private cloud. So like, okay, like what do I need to set in the UI to achieve this? Okay, now how do I translate that to Terraform? Like you go look at the Terraform AWS provider, so you can like kind of map the fields across, and then write that in Terraform, spin that up. Just note, of course, you'd have to be careful because names matter. It won't make something if something's already named that. So you just have to think about how you would decommission the old stuff or like switch over. And there can sometimes be like circular dependencies and things like that. But I think starting small, like picking a small thing to build is a really good way, a really good starting point. I did have to learn the hard way a little bit at Multitudes, just like being on my own and like, how do I build this in Terraform? But the Terraform managed providers, whether it's Google, AWS, Microsoft, are really good. And usually you can also find like someone on the internet has done it. And actually recently, Claude has been really good, Claude AI. Just be like, can you just please write me a Terraform thing for this? I need this alarm for my CPU utilization on RDS. Can you do that for this module? And it's actually pretty good. So I would also recommend like ChatGPT, all those sorts of things to help you.
So this, I think you answered the question. You said you were on your own, so you did your own Terraform templates.
Yes, yeah. So at Halter, I was lucky. I worked with a DevOps person, which was really helpful because I learnt some things. I learned like what this mysterious Terraform was, and then when I moved to Multitudes, was like, okay, this is it. I'm the person. So it was just a good way to learn things fast when you're suddenly the it person. Like I'm the person everyone goes to when something goes wrong. There's no one else. I have to figure it out. There's no one above me. I can't go to my CEO. So that's like a bit of an eye-opening experience.
You're the expert by default.
Yeah, pretty much.
Yeah, no, I think there's a lot of people, I'm sure, that are nodding their heads going, yeah, that's me too. Like it's very common in the data engineering space.
Yeah.
How did you handle the domain knowledge understanding when making these data sets, given the diversity of the companies you worked at?
Yeah, good question. So at Rocket Lab, I was a bit of a space nerd. So I don't know if anyone had heard of Kerbal Space Academy. Anyone's played that game? Where you like launch rockets. It's like a little game with these little aliens. So I kind of knew like some very basic stuff about rockets, very basic. I was also a SpaceX nerd, so I'd like follow all of the SpaceX launches and
my friend works at SpaceX. I should introduce you to.
That's cool. Yeah, I would love to work at SpaceX, but I'm a New Zealand citizen. So that kind of helped. But yes, when I first started, they were like, okay, like we need all these metrics computed. And I actually had to read like, I think it's called like the Rocket Science Bible from NASA from like the 60s. This is like, the rocket science has not changed from when we went to the moon to today. It's the same. So I had to read this, like, I think it's like the liquid propulsion elements or something. This like really scary textbook with all this intense math. So I read that. It took me so long. And learnt like all the equations, what they were, so that I could then compute those equations for my engineers. And then as well, just like sitting and working with them, right? Like I'm not just a data engineer in the head office doing my thing and they're actually at the test site, doing the job. I do think that's the most useful thing is just sit with them, just learn for a little bit. Like, hopefully your company will allow you to do that. But that was, the most useful thing. Same with the cows. Like while I was like a farm girl, I didn't know much about the dairy industry. I didn't know like what a dairy cow, like what that meant, that they're brought in twice a day for milking and that there's a whole like breeding situation. So yeah, I was like there most days on farm, like seeing it all happen, which was just really helpful to build the data and sort of see things from the farmer's eyes and what they needed to know. So yeah, and then same with Multitudes, but again, I'm a developer, so it's a little bit easier to like understand that data. But yeah, just sitting with your customers, your people, whoever's generating the data, I think is just the most useful thing you can do.
That's a huge. So the question was, how did you handle it, right? As I was listening to you, it's like I handled it. You sat down and you did it. Like it was hard. You did it.
It was hard. Yeah, lots of wiki pages of like, okay, this is what I'm doing. Like this is what this means, and this is what this means. A big lot of wiki pages and explaining like why certain decisions were made, especially at multitudes where we don't control the source data, right? Like GitHub sends us data. I have to make sure that the way that we're computing a metric is correct based on what GitHub is telling us. So having just literally just expo dump into a wiki page of like, okay, here's the data, here's how we're computing this, here's why, like we don't get this field, so we have to use this field. That is really useful because then when you're like looking at something that's like maybe not doesn't look right in the data, you can go back to your like reasoning back then and be like, oh yeah, we had to use like this field because we can use that field, and this is how we compute this metric. Yeah, I do think documentation is really key. Just like as you go, like it doesn't have to be fancy. I literally just have a dump a wiki page with like maybe some code blocks, just write some stuff. Yeah, I do find that that's very, very helpful to just remember why you did certain things.
And then, so sitting next, right, milking a cow is very visual, but you also said that you sit in on UX meetings, right, with your developers. So I think that's, would you say that's underrated? Like, do you think
It's
more people
definitely
should do
different.
that? It's different. It is different. I think there's a lot of value in it, but I also know that we are nerds and we like dark mode and to be behind our screens
Yeah.
and to not necessarily that we want to be left alone, but we kind of do want to be left alone. Like we enjoy
Yeah,
our
fair
own
enough.
company. So for someone
Yeah.
who finds that hard, because I find it hard. I mean, I know that might be hard to believe if you spend any time with me, but it's hard.
Yeah.
It takes a lot of effort. For someone who, I mean, is just introverted and just can't, like, it's, what advice, like, would you, like, was that hard for you to, did you had to get out of a comfort zone to get to where you're at now?
Um, do you realize the hardest place it was at Rocket Lab, I'll be honest,
Mm-hmm.
because it was like, rocket science, like, these were people
Right.
that were very smart, in like quite a high pressure job, right? Like you're literally lighting an engine on fire, like stuff could go wrong. And you're there while it's happening. And so you don't want to like get in the way or like, you see them kind of like using the software and you're like, are you okay? Like, so at the beginning it was like a bit hard because I just felt a little bit like I am not smart enough to be here. These people are very, very smart and they've like built this thing and they're testing it and it's very scary. So that like took a bit of an adjustment. But in terms of like jumping on a call, I guess I'm very used to it now. Like I'm a bit of an extrovert. I guess I'm a bit different in that sense. So I was like kind of happy to like jump on and chat with customers. But if that's not your thing, which is totally fine, I know that like most companies that we do, they'll usually have like UX notes. So they'll like, here's the notes from the meeting that we learned about. Like, at least reading those. You don't have to go to the meeting if you don't want to, but reading those notes, reading like what came up in the meeting, what the customers were saying, what the customers want. I think is really, really, really still helpful, even if you're not there chatting with them. Yeah, and like also nowadays, like jumping on a UX call, I'm not seeing anyone in person. I'm still like at home on my computer, so I guess it's not as daunting. But yeah, it takes a bit of time. Maybe you're outside your comfort zone, but it will be hopefully worth it at the end.
Then you also talked about culturally. I made a note you wrote down. We only collect data if we can give back value from it. How do you? So I've had projects where, we ask, what's the business question from this data, and the analyst says, like, I don't know yet. We need to explore it. We need to kind of find out. How do you, I guess, implement that in practice? Like, how do you, I guess,
Yeah.
how do you discover, like, what is that? I guess if you add a little color to that, like, what are some lessons learned, best practices, to 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 do it? I really liked it.
Yeah, so yeah, basically with multitudes, we, for any given thing we integrate with, we deliberately like limit the scopes. So like when you go to install it, we say like, oh, we'll have access to like pull requests, commits, and comments, and that's it. That's all we have. We don't want any more than that. That's all we need. Because we're like, okay, what are the features? What are the features on the roadmap in the next year? What are the features we need to build now, and like what's the sort of minimum level of permissions and scopes and data that we need to deliver that? It does mean a trade-off, right? So sometimes we're like, oh, we actually also want this data because we're going to build this feature like 6 months later. We do have to then like get our customers to like reinstall, like if you could please go and update it so that we have this data. But for our customers, that is worth it for them, because oftentimes they don't like people I think are a bit more aware nowadays of like just not signing up to this thing and giving all of their data, especially because we work with software companies, right? So we're already working with very like technical people. So our customers kind of appreciate that we have very limited scopes, and they're quite happy to be like, okay, cool, I'm going to like give you more data once there's a reason for it. So it just means you have to maybe be a bit careful about how you build things. So building with minimum scopes, but also building in a way that you can add more later in a way that's easy, and then as well in a way that you can add more data later that is easy to do.
Super cool. Well, this has been great. Those were all the questions. Thank you for sacrificing. Are you gonna go back to sleep or have breakfast?
I don't know, that it's kind of, the sun's coming up now, so I'll probably go to my horse, to be honest.
Oh, awesome.
Go for a horse ride.
Thank you so much. And
no, thank you.
It was a pleasure. Thank you.
Awesome. Thank you very much.